Hi, welcome back to Key Concepts in Technology. This is the introduction to week 9. This week we will get an overview of the history of computer design and the design communities around computers from mainframes to mobile devices. And we'll roll up what we've learned so far in a case study on de-blackboxing the iPhone. You'll be able to use the concepts and methods we've learned to analyze the iPhone as an implementation of cumulative combinatorial modular design that bundles up many prior functions, including the development of computers as information appliances and multimedia and metamedia devices as we explored last week. You'll also have a chance to do a DIY, a do-it-yourself project, on a module and a component as an interface to the larger system that makes what we can't see, but that makes everything we can see work the way we perceive it to. Now, there's many good books on the history of computing, but most histories, especially popular books and those covering business and industry, construct familiar narrative structures of progress and heroic innovators, either a linear industrial evolution, but more recently, especially stories of revolution, with strong doses of hype and technology cheerleading. One historian famously deflated all the hype about the digital revolution by asking, who's in charge after the revolution, and will regular elections be held? As Michael Mahoney points out in his important article in the readings this week, there are actually multiple histories of computing and multiple applications developed in different communities and practice over the last 60 years. The conceptual models for computation that we've seen in many kinds of applications came through war, government needs, business efficiencies. These were earlier motivations, but as we've seen, computation can be implemented in many forms, as we see in all of our multimedia devices. There's no determinative principle in computation itself that says how we can apply it. So it's important to gain a sense of the conditions that enabled the development of computers, from Alan Turing's discoveries about computation down to our PCs. But most histories of the computer are so machine-centered. Machines give us the illusion of being empirically factual, representing an agency of their own outside the many intersecting forces of human agency that made them possible. If you go further in the history of computers, you'll discover all the interrelations with forces like government and military funded research during and after World War II for very special purpose computers. The parallel histories of basic science research, electrical engineering and mathematics, and the development of business machines. And then the development of what we call all-purpose computers, the smaller computers leading to our PCs and our handheld devices. It's important to see that none of this history was predetermined or inevitable in the concept of the computer. And the further you investigate, you'll be bringing into view other necessary dependencies closed off in the black boxes of computational devices. Well, I'm sure you can tell by now that the real story of how we got where we are today is one of complex design principles and the participation of many actors and agents in the development of computers. With the methods we've learned so far, you'll see it's precisely this invisible, cumulative, and still accruing multidimensional history from many communities and many kinds of agency that's behind the interfaces in our shiny black boxes, our well-productized devices that we're persuaded to believe were invented last year. This lesson will continue with my presentation of a method that you can use for de-blackboxing the iPhone. I call it system hacking. I'll be merging concepts and methods that you can use for your own do-it-yourself method for any other computational device. Now, we're only using the current model of the iPhone 5 as a convenient, concrete case of a complex modular combinatorial design with specific physical components that we'll hack into conceptually to reveal the necessary system that it's connected to. So for de-blackboxing, we need to push back against the forces of productizing, marketing, advertising, and hype to get at the key design principles and the complex interdependent networks that enable any wireless mobile device to function at all. We'll investigate examples of actual manufactured components, the physical and material things we can see if you open up an iPhone, and how they function as interfaces to the invisible network of dependencies that we can't see. By analyzing physical components as interfaces to the larger networks of necessary conditions and agencies, we discover that this invisible network is as essential to how things work as the electricity flowing invisibly through the device. For example, there are dozens of social forces that have to be synced up. We could talk about standards and policies and licensing agreements, account transactions, manufacturing contracts for hardware and software according to specifications, before you can even stream one bit of digital music through your device and into your earbuds. We'll see how you can use the digital audio processing chip, the codec chip, as an interface to everything that has to be in place before it can process any music file that we take for granted that the device just seems to magically play. Well, now we have a method to sync up what we can't see with things that we can see.